Today, we're going to be doing a challenge, a scientific investigation, where we try to use our snap circuits to demonstrate something. So today we're looking at planning and conducting a scientific investigation where you conduct this investigation, and it's going to be converting. Converting could mean change. So you're converting stored energy, which comes from our batteries, the chemicals in the batteries making electricity, and that stored energy is going to change into motion, light, and sound. Now this is based on a NextGen Science Standard. So our goal here is to follow our NextGen Standard, which is 4-Physical Science 3-4 Energy. And I'm going to start off by showing you a device that will convert electrical energy into another form of energy, including motion energy, magnetism, and then sound. And then after that, I'm going to challenge you to use your snap circuits to build circuits that will make light, motion, and sound. So, if you can come over and help hold the camera, we'll take a look at something that I already built on the desk. I'll give this to you. Start with me. So, back on my desk, I've taken some devices and put them together. And we're going to start off by using electrical energy to make this motor turn. So this motor is an old sewing machine motor, for goodness sakes. And that sewing machine motor uses electricity to turn. And it will turn this belt. And this belt then will be pushing and pulling on this large pulley, which turns a shaft. This shaft has other pulleys attached to it. And these pulleys are going to turn a secondary shaft. This shaft has more pulleys and belts that will make an object turn, still using mechanical motion, but also it has this chain attached. The chain's going to act like a belt as well, and the chain is going to make this device turn. Inside the base of this device is a coil of wire. This coil of wire is going to be turned past these 5 magnets. These pieces right on top are magnets. When you turn a coil of wire past magnetism, you can generate electricity. So turning this is going to change mechanical motion into electrical energy. The electrical energy is going to come out over here, go through wires, which brings it over to these 2 coils. These coils are going to make magnetism. It's going to pull on one side and then switch off and pull on the other side. This is going to make this toggle back and forth, striking these bells, which produces sound. So we're going to use electricity to end up doing lots of things, including making sound. And this switch will control the electricity. So let's give it a try. So we have mechanical motion from electricity, producing motion that turns other things, including mechanical motion up here. It also turns this chain, making electricity here. Electricity then makes this move, striking the bell, making the bell sound. Now today, we're going to have you guys using your snap circuits, using stored electrical energy from the batteries to make 3 things. I challenge you to make light. I challenge you to make mechanical motion. And I challenge you to make sound. So let's see you do that. So over here we're going to let's have a sound team right here. If you think you can do sound, let's see it at this station. If you think you can make light, let's build it over there. If you think you can make mechanical motion, let's get it done here. Let's get started. Let's see if you can do it. Let's work together. So, what's our challenge over here? All right, so you're going to try mechanical motion over here from electricity stored in the batteries from chemical. All right, let's see what we can do.
Where's the motor?
Motor, Dakota's got it.
So she can use it.
Okay.
Work together.
Let me put it here. We need a switch.
So you guys have our motor. You're going to control that motor with a switch. You're using electrical energy coming from these stored chemicals in these batteries. Let's see if you can make it turn. If you need the snap arms, they should be over here. That's right. Get the sizes you need.
This reacts to light with a screeching type sound, so we don't need that.
Okay. Let's see if we can make sound out of this team.
Do we want to do happy birthday music? Here we go. Space Wars? We already got it. Space Wars. Got it. Space Wars is how
You have light already?
Yeah.
Let's see what we got.
I made a morph machine. Where'd you find this, Grace?
What?
So you're able to control that light with a switch.
With a on-off switch.
Okay. So our stored electrical energy is in these batteries as chemicals.
It'll travel down this wire
Okay. That's the negative side. That's good. That's correct.
Into
Electrons
here.
get pushed.
onto this little machine.
Okay.
Which changes this, which plugs it here, allows this to go. Once I flip this, it allows it to connect, going through this, activating, going through the filament in the light bulb, and then traveling back out through here so that it can be reused.
So now it's a complete circuit.
Complete circuit.
So we have a complete path. The electrons can make it all the way back, and that will make the electrons flow. Good. Excellent. Can you make a different light source or add more than one light to the same circuit?
Oh, yes.
See if you can make additional light in the
bulb
same
right here.
circuit.
Light bulb?
Ooh, we're making quite good progress over here. I wonder if it'll work. So your challenge is the sound challenge.
We don't have any more ones, so we're gonna have to just keep creating.
Okay. Everybody participates. I want to hear your ideas. I want you actually working together.
Yeah, like that. So then that will just like if we need another one. And connect them together.
Let me know when you think you got it. I'll keep coming back. How are we doing over here in the motion?
Not very well.
Well, I have faith in you. Don't give up.
We need a 4.
Do you remember how it matters the direction you put batteries into a remote control? So maybe it matters the direction the circuits from the batteries are pointing?
Maybe we could.
We should get a 4.
Yeah, we'll get a 4.
It sounds stuff, but that's not what we're using.
They're trying to make, not make motion. That's sound.
Get that thing to turn.
Only if they had a 4-piece.
Well, we're not going to be able to get anything up
You
front.
can move this. You can make it closer or farther away. You use 2 2s. Make it farther away to make 5s. You can solve this problem.
Use 3. Whatever you need to fix it. Make it work. Yeah, it's connecting.
I'll be back. Have we modified the circuit? Have we changed it to make it different?
We're
Trying different circuits. Oh, you're using the Oh, this is fantastic. So you are actually generating electricity by turning this. That's mechanical motion. Creating electricity by turning this small little motor in here, which has magnets and coils of wire. So you're turning that, which is generating electricity, flowing through the conductors. Oh, this is fantastic. Look at that. All right, keep working. Good job. How are we doing?
Maybe 2. We had instructions from their team.
Oh, no instructions. You have to figure this out.
Hey, we got 2 bats. Or that 1 bat. Make sure it's generating light. We need another one. Here's one. Can I borrow a 3? We don't have any.
You may want to start simple and build. You may want to start with 1 power pack, 1 battery set, and see if you can make it work that way.
Maybe let's try.
Do you have to have the controlling unit before the speaker? Does it matter the direction?
Try that.
How are we doing? Keep going.
Not very good.
Well, I have faith in you. Don't give up.
They're being rude because they're not giving us any parts.
Well, then you gotta discuss it. We can work together. We can figure it out.
I was gonna ask.
All right, let's go ask. What part do you need?
How's it going for you?
What part do you need?
No spinning. That's that. Turn it on.
Is your motor spinning?
Maybe we should just use
Maybe
one
something
battery.
is wrong.
Use one of these. Use one.
Well, that's up to you guys. Figure it out.
Try using one.
So turn the other direction, Dom. Oh, what do we got?
I need the crank.
We have the first sound over here. Now turn the other direction. So this is DC power. DC is one direction, so it only turns one direction to make the sound. Okay, go back the other way again.
Oh, that's so strange.
Now try swapping out your generator with just one battery pack and see if you can make the sound with stored energy in the batteries. Replace this with this and see what happens.
If it makes sound or not.
It might be one direction or the other though.
Wait, you just placed it wrong because positive and positive does nothing. Or does it?
Ah, so now we're using stored energy to make something as simple as this.
I need to see. I know what I'm doing. That sounds like a fire.
Good job. All right, so far, come check out that circuit. We'll keep checking out your circuits. We'll keep building. So we are working on making stored energy from the batteries, electrical energy in the battery, into motion, light, and sound.